Next, we have Tim Chung with Google on Enterprise QoS. So we're kind of a little bit behind, so I don't want to stress you if you want to try to expedite. Or is it already uploaded? Or
Yeah.
Okay.
Put them on for the preset.
Okay. Oh, you want to use your
Yeah.
laptop?
Yeah. Still possible.
Yeah.
Just still the VJ.
Yeah. All right.
All right. My name is Tim Chung. I represent the Google corporate enterprise architecture team. So this is the Enterprise QoS talk. So this is the agenda. I'll show some challenges we had, the solutions we came up with, and some best practices. So this is just a note in case you didn't see the title of the presentation, so don't imply anything about google.com from this presentation. And after the iRoot incident, I probably should make a second note. I'm Chinese, but it's entirely. I'm not. Don't associate, I guess, me with any of the iRoot issues. I was recently at a security conference, and the funny thing was every conclusion of almost every prezo was the Chinese did it. Anyhow, let's make this brief. I think the break is coming up soon. So some of the challenges. So obviously the WAN links are a bottleneck in terms of bandwidth, right? So we have limited WAN bandwidth to work with, which makes QoS essential, especially at these links. Obviously, for latency-sensitive applications, such as real-time apps, voice over IP or video, it's very critical that you have the proper QoS for this. Another thing is we have many different apps that we classify. This becomes very challenging in terms of actually having the classification ACL. Also, another challenge we have is we have different agreements with different transit providers as to how much traffic we can actually place in each different classes of traffic or different queues. And obviously, we operate a multi-vendor network, diverse hardware, we're different queue support, 4Q versus 8Q. Another thing about enterprise is that we tend to run IPsec. So QoS over IPsec seems to be a challenge. Performance is very important. And obviously, in terms of operations, we tend to change our classification at least once a week or two. So definitely this is a challenge we have to solve. So it's obvious that from the classification standpoint, you want to do it closest to edge as possible. So this is just one of the best practices. Realistically, this may not be possible, right? So the question is to trust or not to trust your end nodes, right? It would be nice to trust the end nodes classification, but in reality is you probably need to have some kind of, construct some kind of ACL to classify traffic from your end nodes. Especially when you have a very creative user base that have access, have root access or administrative access to your own box. So presumably they can classify all their flows as network control. Okay. So in terms of LAN switches, there's just some standard Cisco ACL to classify certain flows. Port-based classification, by which I mean you're just classifying the layer 4 ports. It's probably not ideal for many reasons, but it may be sufficient for your network. The answer here is, as it turns out, to effect the most amount of good in a short period of time, we decided that we will classify at the WAN edge router instead of on the LAN switches. since this is really where the congestion is happening, right? And one of the things that we did was we paid very close attention to the classification ACL to make sure it's as granular as possible. This is just to account for the fact that layer 4 classification is imperfect. So just because something is port 80 does not necessarily mean it's web traffic, right? This is just an example of the level of granularity we have. We specify the IP addresses as well as the ports, put some counters on them to count the traffic as well. Juniper commit scripts. We use this extensively to handle various issues. The most basic is very simple, right? You have different platforms on your network that use 8 queues versus 4 queues. So you need some kind of commit script to modify your classification ACL to tailor it to the specific platform. This is the most basic. But we also use the commit scripts to modify the classifier to take care of cases where we have these very specific routing instances on certain subset of the routers. And another thing is this. We tend to have policers and shapers, right? So this becomes very problematic if you don't actually use a commit script. So we do actually construct commit scripts that actually takes input from interface tags, look at which platform it's actually currently running on, and which WAN provider is actually the interface connected to. And based on that, we actually have different rate of policers, and sometimes we have shapers. This is necessary, for example, if your physical drop is actually a gig-e, but what you have purchased is actually just 50 megs. Right? So at the end of the day, what we end up doing is this, right? The business logic is actually encoded inside the commit scripts. And this is just a level abstraction. It makes it easier for our deployment engineers to deploy QoS and not really understand and deal with the complexity. And this is being done by the commit scripts. So we, like I said, we have policers. We definitely mark down certain traffic based on the business requirement for that particular link. Some more syntax here. What we constructed in the firewall filter is actually pre-policer and post-policer. So if you wanted to, you can do some basic calculation to figure out how much traffic was being marked down by a soft policer. This is some syntax on the policer. Don't, I guess, imply on these numbers here that these are actually actuals, so it's been modified. So the operational aspects of QoS. This is very important. Our network is fairly large, so we want to effect changes relatively quickly. And at the same time, we like to be able to have some statistical counters to look at what we have changed. The solution here is not my creation, but actually our security team at Google. We use, they actually built this ACL generation program called Caprica. So this is the URL if you want to look at this. So the next few slides I have borrowed from our security team with their permission. Essentially, Google matches its ACLs from this system. It's actually open source recently under Apache 2. And pretty much all the ACLs constructed at Google uses this Caprica infrastructure. So at a very, very high level, essentially what you have is you have these network definition files that essentially has IP addresses, and you have service definition files For example, port 80 is WW is actually port 80, 443 is SSL, etc. And what you do is you create a policy file, and then when doing generation, you actually have vendor-specific code that actually converts this meta language to a vendor-specific ACL. So this is an example of a network definition file. As you can see, RFC 1918 is 10/8, and then 172 and 192 here. So service definition file, very straightforward. Here's an example of how we construct ACL for QoS classification. Here I'm classifying voice traffic, and this is the meta policy language. And this is the generated ACL. Next, BGP or QoS over IPsec. This actually came up recently in the last few months that which was very interesting. Essentially, we have to use BGP to glue most of our offices together, even the ones connected via IPsec. So which means we run BGP inside the IPsec tunnel. And for one reason or another, the BGP was actually dropping. As it turns out, this seems to be a Juniper feature where despite the fact the routing engine traffic, or BGP, is present in 6, it actually stuffs it in Q0, which is associated with basically best effort. This normally is not a problem until you have a service pick involved where the host-based traffic gets stuffed inside IPsec header, and when it egress out, it has to go out a real pick interface that has a rewrite rule. And why is this a problem? This is a problem when the inner TOS byte is copied out from the inside header to the outside IPsec header. But as soon as you egress out of the service pick back to an outgoing pick, the rewrite rule actually rewrites it to effectively 0, because as a source from the routing engine, the packet is actually associated with the forwarding class of basically best effort. There's a way to fix this. I think GNOS 10.0 or above actually allows you to classify host-based traffic on the egress direction. Some best practices. Essentially, you have to know your applications, how many types of applications you have, what to classify in each class. Another thing is you have to know your platforms. If you have Juniper routers, so don't expect to send 10 gigs of traffic hitting the 100th term with 64-byte packets. You'll definitely not get the full 10 gig throughput. Cisco, I think a lot of people are aware of TCAM issues. So just because you can construct a policy language, a file, don't expect the generated Cisco-specific syntax to be able to fit on the TCAM, right? Last thing is pretty much test everything. This is very important. I always have an XA traffic generator in the lab running a bunch of tests. So before you go live, make sure that you tested everything and worked out all the issues and bugs. And obviously monitor everything. We have NetFlow running as well as counters from the firewall counter that we actually graph. And in case you want to know a little bit more detail on some of the stuff I mentioned, here's some URLs. And that's pretty much it. Questions? All right, nice and short. Thanks.